Chapter 4. Atomic Structure. The year is 1955, and it is a year full of historic events. In the small town of Anaheim, California, the conversion of 160 acres of former orange and walnut groves into a new theme park, Disneyland, is completed. Popular TV shows like I Love Lucy fuel an explosion in the growth of television ownership, from 9% of American homes to 64% in only 5 years. In Montgomery, Alabama, an African-American woman named Rosa Parks refuses to give up her seat on a bus to a white passenger, sparking the equal rights movement. And at Penn State University, physicist Erwin Muller and his student Kanwar Bahadur become the first men to see atoms. Of course, they needed a special tool to see them, the field ion microscope, which the two scientists co-invented. Incredibly, scientists had discovered much about the structure of atoms long before they ever saw them. In this chapter, we'll look at some of the models that scientists developed to explain the atomic world and how these models changed in light of new evidence. 4.1 Early Thoughts about Matter. Questions. Who conceived of the idea of atoms? What evidence led to the acceptance of the atomic model? What was Dalton's atomic model? Terms. Law of definite proportion. Law of multiple proportions. How has our understanding of matter changed through history? Investigating atoms. Our ability to image atoms has improved since 1955. More recently, scientists have used a technique known as scanning tunneling microscopy, STM. But before the invention of such powerful instruments of observation, most of the evidence about atoms was collected indirectly. Scientists ingeniously used fragments of evidence acquired over nearly 2 centuries to piece together different theories called atomic models. These models are foundational to what we know about chemical and physical properties of matter, chemical bonding, and chemical reactions. As scientists continue to study matter, they continue to revise their models. The current model is itself open to further revision. Christians are not troubled by science producing models rather than ultimate truth because they realize that the purpose of science is not to provide the ultimate answers for life. But this does not mean that Christians are unconcerned about research or about improving existing scientific models. Our God-given curiosity leads some of us to studying chemistry, and those who are so led will use that knowledge to manage His creation wisely. These scientists are interested in working with the most accurate models to better perform their work. Atoms. From philosophy to science. The ancient Greeks debated about the nature of matter. Some of them, including Aristotle, held to a continuous theory of matter. They believed that matter could be continuously subdivided without end. This idea was an offshoot of the Greeks' purely mathematical view of the world, where dividing something in half always resulted in 2 new wholes that could be divided in half again. Other Greek philosophers disagreed, believing that matter was made of separate, discrete particles, an idea known as atomism. Democritus is usually credited with articulating this position. He said that matter contained definite particles, and that it could not be divided infinitely without losing its properties. The Greek word that Democritus used to name those smallest particles, atomos, means cannot be divided. Today we use the term atom to mean the smallest particle capable of chemical interactions. Belief in philosophical atomism continued throughout the classical and medieval eras, but it was not widespread. It wasn't until the 17th century that people started to see compelling evidence that matter in fact is composed of atoms or particles. Philosophical atomism was thus replaced by scientific atomism. Small illustration note. Democritus believed that atoms of solids had hooks holding them together, that liquids' atoms were slippery, and that atoms of salts and spices were sharp. Many scientists during the 17th and 18th centuries grappled with the particle theory of matter. Famous men of science such as Isaac Newton, Robert Boyle, and John Dalton disagreed on whether matter is continuous. The first real experimental support for the existence of atoms was finally obtained in the late 1700s. But no one recognized the full significance of this data for several decades. 18th century chemists observed that compounds always contained a set ratio for the masses of elements in the compound. This was true regardless of how much of the compound was analysed or where it came from. For instance, decomposing a 9.0 gram sample of water always produced 8.0 grams of oxygen and 1.0 grams of hydrogen, a ratio of 8 to 1. Decomposing an 18.0 grams water sample produced 16.0 grams of oxygen and 2.0 grams of hydrogen, the same ratio as the smaller sample. Any sample of water always contained 8 grams of oxygen for every 1 gram of hydrogen. Further experimentation with many compounds confirmed that the ratios of composition by mass were unique and constant for each compound. This discovery led to the law of definite proportion, formulated by French chemist Joseph Proust in 1794. This law states that every compound is formed of elements combined in specific ratios by mass that are unique for that compound. The exact values in Dalton's table were not accurate. In some cases, even the order of elements from smallest to largest was incorrect. Nevertheless, Dalton's accomplishments were notable, given the small amount of information available to him. His theory inspired new experimentation that brought new insights into the nature of matter. Within 50 years, many scientists had accepted the atomic theory, and chemistry advanced significantly. Dalton's model is still the foundation of present atomic theories.